You have already studied about environment in your earlier classes. Environmental studies deals with the sum of all social, economical, biological, physical and chemical interrelations with your surroundings. In this unit, the focus will be on environmental chemistry. Environmental chemistry deals with the study of the origin, transport, reactions, effects and fates of chemical species in the environment. Let us discuss some important aspects of environmental chemistry. Let us study the environmental pollution. Environmental pollution is the effect of undesirable changes in our surroundings that have harmful effects on plants, animals, and human beings. A substance which causes pollution is known as pollutant. Pollutants can be solid, liquid, or gaseous substances present in greater concentration than in natural abundance and are produced due to human activities or due to natural happenings. Do you know an average human being requires nearly 12 to 15 times more air than the food? So even small amounts of pollutants in the air become significant compared to similar levels present in the food. Pollutants can be degradable like discarded vegetables which rapidly break down by natural processes. On the other hand, pollutants which are slowly degradable remain in the environment in an unchanged form for many decades. For example, substances such as dichloride, phenyl, trichloroethane, DDT, plastic materials, heavy metals, many chemicals, nuclear waste, etc., once released into the environment are difficult to remove. These pollutants cannot be degraded by natural processes and are harmful to living organisms. In the process of environmental pollution, pollutants originate from a source and get transported by air or water or are dumped into the soil by human beings. Then we are studied about atmospheric pollution. The atmosphere that surrounds the earth is not of the same thickness at all heights. There are concentric layers of air or regions and each layer has different density. The lowest region of atmosphere in which the human beings along with other organisms live is called troposphere. It extends up to the height of 10 km from sea level. Above the troposphere, between 10 and 50 km above sea level, lies stratosphere. Troposphere is a turbulent, dusty zone containing air, much water, vapor, and clouds. This is the region of strong air movement and cloud formation. The stratosphere, on the other hand, contains dinitrogen, dioxygen, ozone, and little water vapor. Atmospheric pollution is generally studied as tropospheric and stratospheric pollution. The presence of ozone in the stratosphere prevents about 99.5% of the sun's harmful ultraviolet UV radiations from reaching the Earth's surface and thereby protecting humans and other animals from its effect. Then we will study about tropospheric pollution. Tropospheric pollution occurs due to the presence of undesirable solid or gaseous particles in the air. The following are the major gaseous and particulate pollutions present in the troposphere. Gaseous air pollutants. These are oxides of sulfur, nitrogen and carbon, hydrogen sulfide, hydrocarbons, ozone and other oxidants. Particulate pollutants. These are dust, mist, foam, smoke, etc. Then we will study about gaseous air pollutants. ए पार्ट है इसका ऑक्साइड्स ऑफ सल्फर. Oxides of sulfur are produced when sulfur containing fossil fuel is burnt. The most common species, sulfur dioxide, is a gas that is poisonous to both animals and plants. It has been reported that even a low concentration of sulfur dioxide causes respiratory disease, example asthma, bronchitis in human beings. Sulfur dioxide causes irritation to the eyes, resulting in tears and redness. High concentration of sulfur dioxide leads to stiffness of flowerbuds, which eventually fall off from plants. And catalyzed oxidation of sulfur dioxide is slow. However, the presence of particulate matter in polluted air catalyzes the oxidation of sulfur dioxide to sulfur trioxide. 2SO2 plus O2 is equal to 2SO3. The reaction can also be promoted by ozone and hydrogen peroxide. SO2 plus O3 is equal to SO3 plus O2. SO2 plus H2O2 is equal to H2SO4. B part, oxides of nitrogen. Dinitrogen and dioxygen are the main constituents of air. These gases do not react with each other at a normal temperature. At high altitudes, when lightning strikes, they combine to form oxides of nitrogen. NO2 is oxidized to nitrate ion, NO3 negative, which is washed into soil where it serves as a fertilizer. It an automobile engine at high temperature when fossil fuel is burnt. Dinitrogen and dioxygen combine to yield significant quantities of nitric oxide NO and nitrogen dioxide NO2 as given below. N2 plus O2 in the presence of 1483 Kelvin is equals to 2NO. NO reacts instantly with oxygen to give NO2. 2NO plus O2 is equals to 2NO2. Rate of production of NO2 is faster when nitric oxide reacts with ozone in the stratosphere. NOO3, NO2 plus O2. The irritant red haze in the traffic and congested places is due to oxides of nitrogen. Higher concentrations of NO2 damage the leaves of plants and retard the rate of photosynthesis. Nitrogen dioxide is a lung irritant that can lead to an acute respiratory disease in children. It is toxic to living tissues also. Nitrogen dioxide is also harmful to various textile fibers and metals. Then C part, hydrocarbons. Hydrocarbons are composed of hydrogen and carbon only and are formed by incomplete combustion of fuels used in automobiles. Hydrocarbons are carcinogenic, that is, they cause cancer. They harm plants by causing aging, breakdown of tissues, and shedding of leaves, flowers, and twigs. Then डी पार्ट ऑक्साइड्स ऑफ कार्बन, जिसमें फर्स्ट पार्ट है इसका ऑक्साइड्स ऑफ कार्बन में कार्बन मोनोऑक्साइड यानी कि CO. Carbon monoxide CO is one of the most serious air pollutants. It is a colorless and odorless gas, highly poisonous to living beings because of its ability to block the delivery of oxygen to the organs and tissues. It is produced as a result of incomplete combustion of carbon. Carbon monoxide is mainly released into the air by automobile exhaust. Other sources which produce CO involve incomplete combustion of coal, firewood, petrol, etc. The number of vehicles has been increasing over the years all over the world. Many vehicles are poorly maintained and several here. It is produced as a result of incomplete combustion of carbon. Carbon monoxide is mainly released into the air by automobile exhaust. Other sources which produce CO involve incomplete combustion of coal, firewood, petrol, etc. The number of vehicles has been increasing over the years of all over the world. Many vehicles are poorly maintained and several have pollution control equipments, resulting in the release of greater amount of carbon monoxide and other polluting gases. Do you know why carbon monoxide is poisonous? It binds to hemoglobin to form carboxyhemoglobin, which is about 300 times more stable than the oxygen hemoglobin complex in blood when the concentration of carboxyhemoglobin reaches about 3-4%. The oxygen carrying capacity of blood is greatly reduced. The oxygen deficiency results into headache, weak eyesight, nervousness, and cardiovascular disorder. This is the reason why people are advised not to smoke in pregnant women who have the habit of smoking. The increased CO level in blood may induce premature birth, spontaneous abortions, and deformed babies. Second part of oxides of carbon is carbon dioxide. Carbon dioxide CO2 is released into the atmosphere by respiration, burning of fossil fuels for energy, and by decomposition of limestone during the manufacture of cement. It is also emitted during volcanic eruptions. Carbon dioxide gas is confined to troposphere only. Normally it forms about 0.03% by volume of the atmosphere. With the increased use of fossil fuels, a large amount of carbon dioxide gets released into the atmosphere. Excess of CO2 in the air is removed by green plants, and this maintains an appropriate level of CO2 in the atmosphere. Green plants require CO2 for photosynthesis, and they in turn emit oxygen, thus maintaining the delicate balance. As you know, deforestation and burning of fossil fuel increases the CO2 level. and disturb the balance in the atmosphere. The increased amount of CO2 in the air is mainly responsible for global warming. The next topic is global warming and greenhouse effect. So, about 75% of the solar energy reaching the earth is absorbed by the earth's surface, which increases its temperature. The rest of the heat radiates back to the atmosphere. Some of the heat is trapped by gases such as carbon dioxide, methane, ozone, chlorofluorocarbons compounds, CFCs, and water vapor in the atmosphere. Thus, they add to the heating of atmosphere. This causes global warming. We all know that in cold places, flowers, vegetables, and fruits are grown in glass covered areas called greenhouse. Do you know that we humans also live in a greenhouse? Of course, we are not surrounded by glass but a blanket of air called the atmosphere, which has the kept the temperature on earth constant for centuries, but it is now undergoing change through slowly, just as the glass in a greenhouse holds the sun's warmth inside. Atmosphere traps the sun's heat near the earth's surface and keeps it warm. This is called natural greenhouse effect because it maintains the temperature and makes the earth perfect for life. In a greenhouse, visible light passes through the transparent glass and heats up the soil and the plants. The warm soil and plants emit infrared radiation such since glass is opaque to infrared heat radiations. It partially reflects and partially absorbs these radiations. This mechanism keeps the energy of the sun trapped in the greenhouse. Similarly, carbon dioxide molecules also trap heat as they are transparent to sunlight but not to the heat radiation. If the amount of carbon dioxide crosses the delicate proportion of 0.03%, the natural greenhouse balance may get disturbed. Carbon dioxide is the major contributor to global warming. Besides carbon dioxide, other greenhouse gases are methane, water vapor, nitrous oxide, CFCs, and ozone. Methane is produced naturally when vegetation is burned, digested, or rotted in the absence of oxygen. Large amounts of methane are released in paddy fields, coal mines, from rotting garbage dumps, and by fossil fuels. Chlorofluorocarbons are man-made industrial chemicals used in air conditioning, etc. CFCs are also damaging the ozone layer. Nitrous oxide occurs naturally in the environment. In recent years, their quantities have increased significantly due to the use of chemical fertilizers and the burning of fossil fuels. If these trends continue, the average global temperature will increase to a level which may lead to melting of polar ice caps and flooding of low-lying areas all over the earth. Increase in the global temperature increase the incidence of infectious diseases like dengue, malaria, yellow fever, sleeping sickness, etc. Then our next topic is acid rain. We are aware that normally rainwater has a pH of 5.6 due to the presence of H plus ions formed by the reaction of rainwater with carbon dioxide present in the atmosphere. Reaction is H2O plus CO2 H2CO3. Then second reaction is Then second reaction is H2CO3 is equal to H plus HCO3 negative. When the pH of the rainwater drops below 5.6, it is called acid rain. Acid rain refers to the ways in which acid from the atmosphere is deposited on the earth's surface. Oxides of nitrogen and sulfur, which are acidic in nature, can be blown by wind along with solid particles in the atmosphere and finally settle down either on the ground as dry deposition or in water, fog, and snow as wet deposition. Acid rain is a byproduct of a variety of human activities that emit the oxides of sulfur and nitrogen in the atmosphere. As mentioned earlier, burning of fossil fuels which contain sulfur and nitrogenous matter such as coal and oil in power stations, furnaces, or petrol or diesel in motor engines produces sulfur dioxide and nitrogen oxides SO2 and NO2 after oxidation and reaction, which water are major contributors to acid rain because polluted air usually contains particulate matter that catalyze the oxidation. Then the reaction is then the reaction is 2SO2 or 2SO2 plus O2 plus 2H2O is equal to 2H2SO4. Then second reaction is 4NO2 plus O2 plus 2H2O is equal to 4HNO3. Ammonium salts are also formed and can be seen as an atmospheric haze. Aerosol particles of oxides or ammonia salts in raindrops result in wet deposition. SO2 is also absorbed directly on both solid and liquid ground surfaces and is thus deposited as dry deposition. Acid rain is harmful for agriculture, trees, and plants as it dissolves and washes away nutrients needed for their growth. It causes respiratory ailments in human beings and animals. When acid rain falls and flows as groundwater to reach rivers, lakes, etc., it affects plants and animal life in aquatic ecosystem. It corrodes water pipes, resulting in the leaching of heavy metals such as iron, lead, and copper into the drinking water. Acid rain damages buildings and other structures made of stone or metal. The Taj Mahal in India has been affected by acid rain. सेकंड पॉइंट है particulate pollutants. Pollutants are the minute solid particles or particulates. Pollutants are the minute solid particles or liquid droplets in air. These are present in vehicle emissions, smoke particles from fires, dust particles, and ash from industries. Particulates in the atmosphere may be visible or non-visible. The visible particulates, example bacteria, fungi, moulds, algae, etc., are minute living organisms that are dispersed in the atmosphere. Human beings are allergic to some of the fungi found in air. They can also cause plant disease. Non-viable particulates may be classified according to their nature and size as follows. Smoke particulates consist of solid or mixture of solid and liquid particles formed during combustion of organic matter. Example are cigarette smoke, smoke from burning of fossil fuels, garbage and dry leaves, oil smoke, etc. Dust is composed by of fine solid particles produced during crushing, grinding, and attribution of solid materials, sand from sandblasting, sawdust from works, cement and fly ash from factories, dust storms, etc. are some typical examples of this type of particulate emission. Mists are produced by particles of spray liquid and by condensation of vapors in air. Examples are sulfuric acid mist and herbicides and insecticides that miss their targets and travel through air and form mists. D. Fumes are generally obtained by the condensation of vapors during sublimation, distillation, boiling, and several other chemical reactions. Generally, organic solvents, metal, and metallic oxides form fume particles. The effect of particulate pollutants are largely dependent on the particle size. Airborne particles such as dust, fumes, mist, etc. are dangerous for human health. Particulate pollutants bigger than 5 microns are likely to lodge in the nasal passage, whereas particulates of about 1 micron enter into lungs easily. Lead, used to be a major air pollutant emitted by vehicles. Leaded petrol used to be the primary source of airborne lead emissions in Indian cities. This problem has now been overcome by using unleaded petrol in most of the cities in India. Lead interferes with the development and maturation of red blood cells. Smoke. Next topic is smoke. Smoke नहीं smog. The word smog is derived from smoke and fog. This is the most common example of air pollution that occurs in many cities throughout the world. There are two types of smog. A. Classical smog occurs in cool, humid climate. It is a mixture of smoke, fog, and sulfur dioxide. Chemically, it is a reducing mixture, and so it is called as reducing smoke. B. Photochemical smoke occurs in warm, dry, and sunny climate. The main components of the photochemical smoke result from the action of sunlight on unsaturated hydrocarbons and nitrogen oxides produced by automobiles and factories. Photochemical smoke has high concentration of oxidizing agents and is therefore called an oxidizing smoke. Then the next topic is formation of photochemical smoke. When fossil fuels are burned, a variety of pollutants are emitted into the Earth's troposphere. Two of the pollutants that are emitted are hydrocarbons and nitric oxide (NO). When these pollutants build up to sufficiently high levels, a chain reaction occurs from their interaction with sunlight, in which NO is converted into nitrogen dioxide (NO2). This NO2 in turn absorbs energy from sunlight and breaks up into nitric oxide and free oxygen atom. Then the reaction is NO2 2 is equal to, in the presence of HV, NO plus O. Oxygen atoms are very reactive and combine with the O2 in air to produce ozone. Then the reaction is O plus O2 is equals to O3. The ozone formed in the above reaction reacts rapidly with the NO formed in the reaction to regenerate NO2. NO2 is a brown gas and at sufficiently high levels can contribute to haze. Then the next reaction is NO plus O3 is equals to NO2 plus O2. Ozone is a toxic gas and both NO2 and O3 are strong oxidizing agents and can react with the unburnt hydrocarbons in the polluted air to produce chemicals such as formaldehyde, acetylene and peroxyacetyl nitrate (PAN). Then the reaction is 3CH4 plus 2O3 is equals to 3CH2 double bond O plus 3H2O. 3CH2 double bond O is formaldehyde. Then CH2 double bond CH double bond O, acetylene, and the next CH3 the next CH3 COO NO2. The next CH3 COO C double bond OO NO2. This is peroxyacetyl nitrate. Then the next topic is effect of photochemical smoke. The common components of photochemical smoke are ozone, nitric oxide, acetylene, formaldehyde, and peroxyacetyl nitrate. Photochemical smoke causes serious health problems. Both ozone and PAN acts as powerful irritants. Ozone and nitric oxide irritate the nose and throat, and their high concentration causes headache, chest pain, dryness of the throat, cough, and difficulty in breathing. Photochemical smoke leads to cracking of rubber and extensive damage to plant life. It also causes corrosion of metals, stones, building materials, rubbers, and painted surfaces. Then the next topic is how can photochemical smoke be controlled? Many techniques are used to control or reduce the formation of photochemical smoke. If we control the primary procedures of photochemical smoke such as NO2 and hydrocarbons, the secondary precursors precursors such as ozone and PAN, the photochemical smoke will automatically be reduced. Usually, catalytic converters are used in the automobiles, which prevent the release of nitrogen oxide and hydrocarbons to the atmosphere. Certain plants, example pinus, juniperus, and vitis, can metabolize nitrogen oxide, and therefore their plantation could help in this matter. Then the next topic is stratospheric pollution, formation and breakdown of ozone. The upper stratosphere consists of considerable amount of ozone O3, which protects us from the harmful ultraviolet radiations 255 nm coming from the sun. These radiations causes skin cancer in humans. Therefore, it is important to maintain the ozone cell. Ozone in the stratosphere is a product of UV radiations acting on dioxygen molecules. The UV radiations split apart molecular oxygen into three oxygen atoms. These oxygen atoms combine with the molecular oxygen to form ozone. Then the reaction is O2 in the presence of UVO3. UV, then product is O plus O2 in the presence of UV radiation O3. Ozone is thermodynamical unstable and decomposes to molecular oxygen. Thus, a dynamic equilibrium exists between the production and decomposition of ozone molecules. In recent years, there have been reports of the depletion of this protective ozone layer because of the presence of certain chemicals in the stratosphere. The main reason of ozone layer depletion is believed to be the release of chlorofluorocarbon compounds, also known as pherones. These compounds are non-reactive, non-flammable, non-toxic organic molecules, and therefore used in refrigerators, air conditioners, in the production of plastic foam, and by the electronic industries, the cleaning computer parts, etc. Once CFCs are released in the atmosphere, they mix with the normal atmospheric gases and eventually reach the stratosphere. In stratosphere, they get broken down by powerful UV radiations, releasing chlorine-free radical. Then their reaction is CFCS2 in the presence of UV radiation, Cl plus F2Cl. The chlorine radical then react with stratospheric ozone to form chlorine monoxide radicals and molecular oxygen. The reaction is Cl plus O3 is equals to ClO plus O2. Reaction of chlorine monoxide radical with atomic oxygen produces more chlorine radicals. Equation is ClO plus O, Cl plus O2. The chlorine radicals are continuously regenerated and cause the breakdown of ozone. Thus, CFCs are transporting agents for continuously generating chlorine radicals into the stratosphere and damaging the ozone layer. Then the next topic is the ozone hole. In 1980s, atmospheric scientists working in Antarctica reported about depletion of ozone layer, commonly known as ozone hole, over the South Pole. It was found that a unique set of conditions was responsible for the ozone hole. In summer season, nitrogen dioxide and methane react with chlorine monoxide and chlorine atoms, forming chlorine sinks, preventing much ozone depletion, whereas in winter, special type of clouds called polar stratospheric clouds are formed over Antarctica. These polar stratosphere clouds provide surface on which chlorine nitrate formed gets hydrolyzed to form hypochlorous acids. It also reacts with hydrogen chloride produced as per reaction to give molecular chlorine. And the reactions is ClO NO2 plus NO2 is equals to ClO NO2. Then the second reaction is Cl plus CH4 is equals to CH3 plus HCl. Then the third reaction is ClO NO2 plus H2O is equals to HOCl plus HNO3. And then the fourth reaction is ClO NO2 plus HCl is equals to Cl2 HNO3. When sunlight returns to the Antarctica in the spring, the sun's warmth breaks up the clouds and HOCl and HCl2 are photolyzed by sunlight as given in reaction. Then the reaction is HOCl in the presence of HV, HNu, OH plus Cl, and the second reaction is Cl2 in the presence of HV is equal to 2Cl. The chlorine radicals thus formed initiate the chain reaction from ozone depletion as described earlier. Then the next topic is effect of depletion of the ozone layer. With the depletion of ozone layer, more UV radiation filters into troposphere. UV radiation lead to aging of skin, cataract, sunburn, skin cancer, killing of many phytoplanktons, damage to fish productivity, etc. It has also been reported that plant proteins get easily affected by UV radiations, which leads to the harmful mutation of cells. It also increases the evaporation of surface water through the stomata of the leaves and decreases the moisture content of the soil. Increase the in UV radiation damage pins and fibers, causing them to fade faster. Then the next topic is water pollution. Water is essential for life. Without water, there would be no life. We usually take water as granted for its purity, but we must ensure the quality of water. Pollution of water originates from human activities through different paths. Pollution reaches surface or groundwater. Easily identified source or place of pollution is always as point source. Example, municipal and industrial discharge pipes. Where pollutants enter the water source. Known point sources of pollution are those where a source of pollution cannot be easily identified. Example, agricultural runoff from farm animals and croplands, acid rain, stormwater drainage. Then the next topic is causes of water pollution, and the first part is pathogens. The most serious water pollutants are the disease-causing agents called pathogens. Pathogens include bacteria and other organisms that enter water from domestic sewage and animal excreta. Human excreta contain bacteria such as Escherichia coli and Streptococcus faecalis, which cause gastrointestinal disease. Then the next topic is organic wastage. The other major water pollutant is organic matter, which such as leaves, grass, trash, etc. They pollute water as a consequence of runoff, excessive phytoplankton growth within water is also a cause of water pollution. These wastes are biodegradable. The large population of bacteria decomposes organic matter present in water. They consume oxygen dissolved in water. The amount of oxygen that water can hold in the solution is limited. In cold water, dissolved oxygen (DO) can reach its concentration up to 10 ppm, whereas oxygen in air is about 20,000 ppm. That is why even a moderate amount of organic matter, when decomposed in water, can deplete the water of its dissolved oxygen. The concentration of dissolved oxygen in water is very important for aquatic life. Pollutant and their sources. ये टेबल है मेजर वाटर पोल्यूटेंट्स की. जेल लाइक पोल्यूटेंट है माइक्रो ऑर्गेनिजम्स. जो सोर्स है उसका डोमेस्टिक सीवेज. ऑर्गेनिक वेस्ट पोल्यूटेंट है तो सोर्स है उसका डोमेस्टिक सीवेज, एनिमल एक्सक्रेटा एंड वेस्ट, डिकेइंग एनिमल्स एंड वाटर एंड plants, discharge from food processing factories. Then the next pollutant is plant nutrients, and its source is chemical fertilizers. Next is toxic heavy metals, and their source is industries and chemical factories. And the next is sediments, और उसके सोर्स है इरोजन ऑफ सोयल by agriculture and strip mining. Next is pesticides, and their source is chemicals used for killing insects, fungi and weeds. The next is radioactive substance, and their source is mining of uranium containing minerals. And then next is heat, and their source is water used for cooling in industries. If the concentration of dissolved oxygen of water is below 6 ppm, the growth of fish gets inhibited. Oxygen receives water either through atmosphere or from the process of photosynthesis carried out by many aquatic green plants during daylight. However, during night photosynthesis stops, but the plants continue to respire, resulting in reduction of dissolved oxygen. The dissolved oxygen is also used by microorganisms to oxidize organic matter. If too much of organic matter is added to water, all the available oxygen is used up. This causes oxygen-dependent aquatic life to die. Thus, anaerobic bacteria begin to break down the organic waste and produce chemicals that have a foul smell and are harmful to human health. Aerobic bacteria degrade these organic wastes and keep the water depleted in dissolved oxygen. Thus, the amount of oxygen required by bacteria to break down the organic matter present in a certain volume of a sample of water is called biochemical oxygen demand, BOD. The amount of BOD in the water is a measure of the amount of organic material in the water in terms of how much oxygen will be required to break down. Biological clean water would have BOD value of less than 5 ppm, whereas highly polluted water could have a BOD value of 17 ppm or more. And the third part is chemical pollutants. As we know that water is an excellent solvent, water soluble in organic chemicals that include heavy metals such as cadmium, Mercury, nickel, extra constitute an important class of pollutants. All these metals are dangerous to humans because our body cannot excrete them over the time it crosses to the tolerance limit. These metals that then can damage kidneys, central nervous system, liver, etc. Acids from mine drainage and salts from any different sources included raw salt used to melt snow and ice in the colder climate are water soluble chemical pollutants. The organic chemicals are another group of substances that are found in polluted water. Petroleum products pollute many sources of water. Example, major oil spills in oceans. Other organic substances with serious impacts are the pesticides that drift down from sprays or runoff from rains. Various industrial chemicals like polychlorinated biphenyls, which are used as cleansing solvent, detergents, and fertilizers, add to the list of water pollutants. PCBs are suspected to the carcinogenic. Nowadays, most of the detergents available are biodegradable. However, their use can create other problems. The bacteria responsible for degrading biodegradable detergents feed on it and grow rapidly. While growing, they may use up of the oxygen dissolved in water. The lack of oxygen kills all other forms of aquatic life, such as fish and plants. Fertilizers contain phosphates as additive. The addition of phosphates in water enhances algae growth. Such profuse growth of algae covers the water surface and reduces the oxygen concentration in water. This leads to anaerobic conditions, commonly with accumulation of obnoxious decay and animal death. Thus, bloom infested water inhibits of growth of other living organisms in the water body. This process, in which nutrient enriched water bodies support a dense plant population, which kills animal life by depriving it of oxygen and results in subsequent loss of biodiversity, is known as eutrophication. And the next topic is international standards for drinking water. The international standards for drinking water are given below and they must be followed. Fluoride. First have fluoride. For drinking purpose, water should be tested for fluoride ion concentration. Its deficiency in drinking water is harmful to man and causes diseases such as tooth decay, etc. Soluble fluoride is often added to drinking water to bring the its concentration up to 1 ppm or 1 mgdm -3. The F negative ions makes the enamel on teeth much harder by converting hydroxyapatite 3CA3PO4 का whole 2 in CaOH का whole twice. The enamel on the surface of the teeth into much harder fluoropeptide. However, F minus ion concentration about 2 ppm causes brown mottling of teeth. At the same time, excess fluoride causes harmful effects to bones and teeth, as reported from some parts of Rajasthan. Next is lead. Drinking water gets contaminated with lead when lead pipes are used for transportation of water. The prescribed upper limit concentration of lead in drinking water is about 50 ppb. Lead can damage kidney, liver, reproductive system, etc. Sulfate. Next is sulfate. Excessive sulfate in drinking water causes laxative effect. Otherwise, at moderate levels, it is harmless. Next is nitrate. The maximum limit of nitrate in drinking water is 50 ppm. Excess nitrate in drinking water can cause diseases such as methemoglobinemia, blue baby syndrome. Next is other metals. The maximum concentration of some common metal recommended in drinking water are given in the table. Then the table is Fe 0.2, Mn 0.05, air 0.2, Cu 3, Zn5, Cd 0.005. And the next topic is soil pollution. Then in the soil pollution, India being an agriculture based economy, given high priority to agriculture, fisheries and livestock development, the surplus production is stored by governmental and non-governmental organizations for the lean season. The food loss during the storage also needs special attention. Have you ever seen the damages caused to the crops, food items by insects, rodents, weeds and crop disease, etc.? How can we protect them? You are acquainted with some insecticides and pesticide for protection of your crops. However, these insecticides, pesticides and herbicides cause soil pollution, hence there is a need for their judicious use. The next is pesticides. Prior to World War II, many natural occurring chemicals such as nisotine were used as pest controlling substance for major crops in agriculture pest practices. During World War II, DDT was found to be of great use in the control of malaria and other insect-borne diseases. Therefore, after the war, DDT was put to use in agriculture to control the damages caused by insects, rodents, weeds, and various crop diseases. However, due to adverse effects, its use have been banned in India. Pesticides are basically synthetic toxic chemicals with ecological repercussions. The repeated use of the same or similar pesticide give rise to pests that are resident to that group of pesticides, thus making the pesticides ineffective. There as insect resistance of DDT increased, other organic toxins such as aldrin and d-aldrin were introduced in the market by pesticide industry. Most of the organic toxins are water insoluble and non-biodegradable. These high persistent toxins are therefore transferred from lower trophic level to higher trophic level through food chain. Over the time, the concentration of toxins is in higher animals reach a level which causes serious metabolic and physiological disorders. Sodium, sorry. At each trophic levels, the pollutant gets 10 times concentrated. In response to high presentation of fluorinated organic toxins, a new series of less persistent or more biodegradable products called organophosphates and carbamates have been introduced in the market, but these chemicals are severe nerve toxins and hence more harmful to humans. As a result, there are reports of some pesticide related death of agriculture field workers. Insects have become resistant to these insecticides also. The new group of insecticide, but one has to think in this the only solution to pest menace. These days the pesticide industry has shifted its attention to herbicides such as sodium chlorate, sodium arsenite, and many others. During the first half of the last century, the shift from mechanical to chemical wide, wide control and provided the industry with flourishing economic market. But one must remember that these are also not environment friendly. Most herbicides are toxic to mammals but are not as persistent as organochlorides. These chemicals decompose in a few months. Like organochlorides, these too become concentrated in the food web. Some herbicides cause defects. Studies show that fields sprayed with herbicides are more prone to insect attack and plant disease than fields that are weeded manually. Pesticides and herbicides represent only a very small portion of widespread chemical pollution. A large number of other compounds that are used regularly in chemical and industrial processes for manufacturing activity and finally released in the atmosphere in one or other form. Next topic is industrial waste. Industrial solid wastes are also sorted out as biodegradable and non-biodegradable wastes. Biodegradable wastes are generated by cotton mills, food processing units, paper mills, and textile factories. Non-biodegradable wastes are generated by thermal power plants which produce fly ash, integrated iron and steel plants which produce blast furnace slag and steel melting slag. Industries manufacture aluminum, zinc, and copper, produce mud and linings. Fertilizers industries produce gypsum. Hazardous wastes such as inflammables, composite, explosives, or highly reactive substances are produced by industrial dealing in metals, chemicals, drugs, and pharmaceuticals, dyes, pesticides, rubber goods, etc. The disposal of non-degradable industrial solid waste, if not done by a proper and suitable method, may cause serious threat to the environment. New innovations have led to different uses of waste material nowadays. Fly ash and slag from the steel industry are utilized by the cement industry. Large quantities of toxic waste are usually destroyed by controlled incineration, whereas small quantities are burnt along with factory garbage in open bins. Moreover, solid waste is if not managed effectively, affect the components of the environment. Then the next topic is strategies to control environmental pollution. After studying air, water, soil, and industrial waste pollution in this unit, by now you must have started feeling the need of controlling environmental pollution. How can you save your immediate environment? Think of the steps and activities which you would like to undertake for controlling air, water, soil, and industrial waste pollution in your neighborhood. Here an idea about the strategies for the management of waste is given. Then the strategies is first is waste management. Solid waste is not the only waste which you see in the household garbage box. Besides household decay discards, These are medical, agricultural, industrial, and mining wastes. The improper disposal of wastes is one of the major causes of environmental degradation. Therefore, the management of wastes is of utmost importance. The next is collection and disposal. Domestic wastes are collected in small bins which are then transferred to the community bins by private or municipal workers. From these community bins, these are collected and carried to the disposal site. At the site, garbage is sorted out and separated into biodegradable and non-biodegradable materials. Non-biodegradable materials such as plastic, glass, etc. are sent for recycling. Biodegradable waste are deposited in landfills and are converted into compost. The waste, if not collected in garbage bins, find its way into the sewers. Some of it is eaten by cattle. Non-biodegradable waste like polythene bag, metal scraps choke the sewer and cause inconvenience. Polythene bags, if swallowed by cattle, can cost their lives also. As a normal practice, therefore, all domestic wastes should be properly collected and disposed. The poor management causes health problems leading to epidemics due to contamination of groundwater. It is especially hazardous for those who are in direct contact with the waste, such as rag pickers and workers involved in waste disposal, as they are the ones who handle waste materials mostly without protective device such as gloves or waterproof boots and gas masks. What can you do from them? Chemical. The next topic is green chemistry. Then the introduction is of green chemistry is, it is well known fact that self-sufficiency in food has been achieved in India since late 20th century by using fertilizer, pesticides, and exploring improved method of farming, good quality seeds, irrigation, etc. But over the exploitation of soil, excessive use of fertilizer, pesticides have resulted in the deterioration of soil, water, and air. The solution of this problem does not lie in stopping to the process of development that has been set in, but to discover methods which would help in the reduction of deterioration of environment. Green chemistry is a way of thinking and is about utilizing the existing knowledge and principles of chemistry and other sciences to reduce the adverse impact on environment. Green chemistry is a production process that would bring about minimum pollution or deterioration to the environment. The byproducts generated during a process, if not used gainfully, add to the environmental pollution. Such processes are not only environmental unfriendly but also cost ineffective. The waste generation and its disposal both are economically unsound. Utilization of existing knowledge base for reducing the chemical hazards along with the developmental activities is the foundation of green chemistry. Have you perceived the idea of green chemistry? It is well known that organic solvents such as benzene, toluene, carbon, tetrachloride, etc. are highly toxic. One should be carefully while using them. As you know, a chemical reaction involves reactants attacking reagents and the medium in which the reaction takes place. Extent of many reactions depends upon physical parameters like temperature, pressure, and use of catalysts in a chemical reaction. If reactants are fully converted into useful environment friendly products by using an environment friendly medium, then there would be no chemical pollutants introduced in the environment. During a synthesis, care must be taken to choose starting materials that can be converted into end products with yield approximately up to 100%. This can be achieved by arriving at optimum condition of synthesis. It may be worthwhile to carry out synthetic reaction in aqueous medium since water has high specific heat and low volatility. Water is cost effective, non-inflammable and devoid of any carcinogenic effects. Then the next topic is green chemistry in day-to-day life, and the part of it is dry cleaning of clothes. Tetrachloroethane was earlier used as solvent for dry cleaning. The compound contaminates the groundwater and is also a suspected carcinogen. The process using the compound is now being replaced by a process where liquefied carbon dioxide with a suitable detergent is used. Replacement of halogenated solvent by liquid CO2 will result in less harm to groundwater. These days, hydrogen peroxide is used for the purpose of bleaching clothes in the process of laundry, which gives better result and makes up of lesser amount of water. Next is bleaching of paper. Chlorine gas was used earlier for bleaching paper. These days, hydrogen peroxide with suitable catalyst which promotes the bleaching action of hydrogen peroxide is used. Next is synthesis of chemicals. Ethanol is now commercial prepared by one step oxidation of ethene in the presence of ionic catalyst in aqueous medium with an yield of 90%. CH2 double bond CH2 plus O2 in the presence of catalyst PD second या Cu second in water is equal to CH3 CHO 90%. Next नहीं वहीं से green chemistry in a nutshell is a cost-effective approach which involves reduction in material, energy consumption and waste generation. That's all. Complete this chapter, environmental chemistry. Thank you for listening.